In our previous video, we wound this 9-to-1 unun, but we didn't get to test it with an antenna. In this video, I'm going to continue mounting the 9-to-1 so we can go out into the field and attach it to a random wire antenna and see how it works. Stay with us to the end. You're going to want to see this kind of unique random wire antenna that we're going to build. Those of you that have been following the channel for a while may recognize this as one of the cutting boards that we bought way back several months ago when we were building some of our other baluns and ununs. Use this as a mounting. We got 3 different cutting boards in a package. This is the, I believe, the medium size of the 3 boards, and I've already cut off 2 different pieces. Here is the most recent piece that was cut off, but we're getting a lot of use out of these relatively inexpensive cutting boards, and they do a good job for what we're using them for. So what I've got here is I've already drilled a few holes. There's nothing precision about this. It doesn't have to be specifically like this. You can do it however you need to. This is how I chose to do it, okay? What we're going to do is we're going to mount toroid to the board, and this is the approximate location it's going to go right here. This is the ground wire. It'll come over here and make a connection here. This is the connector to the center conductor of the coax, so it's going to go here. And then this is the antenna wire, and we're going to connect it here underneath these washers. So we'll cut that a little shorter. It's quite long there. And these holes here, so I can run a zip tie through the board and fasten the toroid to the board. And I think that's probably what we're going to do first here. Zip ties are used in a lot of my projects, and for good reason. That they're relatively inexpensive, they work, and so not a big deal. So we're going to run this through here, back through, and we're just going to attach it loosely at first until we get everything where we want it. Pull that down a little bit. Just work it down. And that's as short as I'm going to get it for right now. Cut off a little bit of that so it doesn't poke me in the face or anything. And line up the toroid so it can get around these other 2 holes here. So we'll run it down and through again. Back up over here. Work it down a little bit. And tighten it up a little bit. That's enough for the moment. We'll leave a little length on there so we can grab it and tighten it up. But that's going to work well, just like that. So we got plenty of wire to make all the connections. I'm going to push it as far up into this corner as I can there. Going to get, where's my pliers? Get to my pliers and pull this tight. Alright, there's that one. And now, alright, got that one pulled tight. So that's on there solid, not moving a bit. So we can cut off the excess now. I'm still going to leave just a little bit on it in case I think it might need tightening more later, but I can't see that it will because it is tight right now. Now, I think for this here, I want to put a eye on that to go underneath this washer. So we'll cut this about there. And then we'll strip off about 3/8 of an inch What is that in metric? I'll put it on the screen here if I don't forget it. But now we've got that stripped off. And I believe I have a terminal here already. And we will crimp that on and solder that on and make sure we've got a good connection. So get the crimpers here and always put the split up in this part here, the recess there, if you can see that. Goes like that. Bring the wire up, put it on there, and crimp it down. Okay, that's on there pretty good already. It is not coming off, but I always like to solder it. You don't have to. If you want to, that's fine. If you don't, don't. But I solder mine. Heat up the terminal there, put a little solder on, it draws it in. That should be good. Alright, so we got the terminal soldered on. It's going to be hot for a second, so we're going to let it cool down. Now, down here on the ground, let me bend this out of the way a little bit while it's cooling. I'm going to run this through from this side, like so. Okay. And I've got a little piece of wire here that I'm going to put in there. I'm going to cut it a little shorter. Only need about half of what I've got here. I could have done this differently. This is the way I chose to do it. There's always more than one way to do it. Okay. So what we've got here is we've got a wire in there now that once I solder this, it'll connect the coax shield, which is, this is the back of the SO239 that's screwed on here. And this screw here becomes the electrical and mechanical connection to the SO239. So that's going to be to your shield. And then this will be where you can connect a counterpoise or a ground or nothing. Some people don't want to use either, and that's fine. But when you do that, the shield of your coax becomes the counterpoise, and that's what I'm actually going to use, is the shield of the coax. But when you do that, you need to make a piece of coax between 16 and 17 feet long, and then connect that coax here. But then at the other end of the coax, that 16 or 17 foot piece of coax, you need to put a common mode choke. That will prevent the signal from going any further back up to your radio or into your shack or whatever. That protects you and your equipment from RF. And you don't want RF on you or the equipment. So what I'm going to do here is, I've got some hemostats. You can use some pliers or whatever, but I don't want to overheat this terminal here because it'll melt the plastic. So what I can do is clip this on right here, and that becomes a heat sink. It'll draw the heat away from this screw terminal here in the plastic. At least that's the theory. That's what I've done in the past, and it has worked okay. So I'm going to get this little piece of wire back in here, get the soldering gun again. I don't have enough room on my workbench here, so I put it in the floor. And we'll heat this up. Go ahead and get the soldering iron hot, and if the soldering iron is hot enough, it doesn't have to be connected that long to the terminal itself. So it should heat up there pretty quick. We'll get the solder in there, and that should be sufficient on that side. Do the same thing over here on this side. Now this big bolt over here is going to act like a heat sink. Get some heat transferred to this terminal here. And yes, I could have soldered this before I connected it to the board, but that makes it a little more difficult as far as getting the length correct, because these connectors are already here. So connectors are there. All right, so we've got them connected. Put my soldering gun back in the floor again. Let this cool off a bit. This one up here is cool now. So which way do I want that? I think I'll put it that way. Like so. We can bend these other wires around a little more, which is not going to be an issue. And put that washer on, and we'll tighten that down. We've got another wire that needs to go on there. I'll show you in a minute what that's going to do, what that's going to be. Some will ask, well, why didn't you build this all as one piece? Because we've got something we're going to attach to this in a minute. And I don't build it all in one piece to give me more flexibility. I may want to use this with something other than what I'm going to show you in a few minutes. So building it two different pieces where I've got the 9-to-1 here allows me more flexibility in how I use it. Okay, so we can take this off now. We've got the shield connected to the ground wire. If you remember our schematic, this is connection we're seeing right here. We've got the blue wire C2 connected to ground. This will be our ground, or could be our ground if we use a counterpoise, or if we want to ground that side of the antenna, use the earth ground. And this is going to the shield of the coax here. So that's that connection. And we've got our antenna connection here, which will be connected to our antenna, as you'll see in a minute. And now we've got to connect C1 and B2, the blue and the green, to the center conductor of the coax, which is here. All I've got to do right here is take this and bend it. And it's a little bit long, so let's cut some off there. You see, you've got that little bit there. Let's bend it more at a 90-degree angle and stick it down in there. All right. Now we just have to put a little solder there, and our electrical connections will be complete. So get the soldering iron again. Soldering gun, and we'll heat it up and make that connection. All right, should be good. Should be good. Get the solder out of the way here. So we've got our 9-to-1 unun mounted to its board, bracket, whatever you want to call it, with all of its electrical connections made. think that looks pretty good. So now what? Well, we need to build an antenna, and this idea is not original, but I'm not opposed to using other good ideas. I hope you're not either. This is a chalk line, or it was a chalk line. As you can see, I've already taken the string out of it. Now, if you can't find one identical to this one came from Harbor Freight, and you might not have access to Harbor Freight, but you can find something similar to this either on Amazon, eBay, or wherever you buy items of this type. This is item number 93818. Item 93818, if you want to try to buy this. This was less than $5. It came with the chalk line, the chalk, and a string level. Hey, it's pretty good value. Well, I took now one thing when you're shopping for these, you need to get one that has the capacity of 100 feet of string. We're not going to be using 100 feet of wire though, but you need the capacity of 100 feet of string in order to fit in 41 feet of 22 gauge wire. Now if you go with the smaller gauge wire, of course you can get more on the spool. As you can see here, this has 2 screws on the back of it. Here and here, Phillips head screws, and it comes apart. I'll take it apart and show you. It can be a little fiddly. Is that a word where you are, fiddly? Getting it back together. But it's not hard because there is a spring inside, so anytime you open one of these up the first time, you need to be aware there may be small parts inside that will fall out. So you don't want to be out in the yard in the grass or whatever where you can't see them. And it has this little door here on the side. This is where you would put the chalk in if you're running a chalk line. Let's take this off and look what we've got here. See, there's just a spool here, and the other side has a crank on it and a gear, but I'm not going to turn that over. And what I found is you're going to want this wire. You see the doors here, so you want the wire on the door side of the spool, okay? Again, this is that fiddly part I was talking about. You've got to have things lined up, and because it's got this little wiper up front here. You may or may not need to use that wiper. That wiper is to wipe excess chalk from the line and keep the chalk from coming out the end of it. We're not going to be using chalk, of course, but it also will wipe the wire down. Now, see here, the door fell in. It's got to go in the groove. There's a groove in the bottom section. There's a groove in the top section. So we'll take that back out. We'll line this back up like so. Put that down in there like that. And we need to come straight down from the top so that everything lines up. Okay. And now the door is in the grooves. Slides back and forth, and the wire, we can see the wire down in there. See the wire? So we'll go ahead and put the screws back in. Now the way the wire is attached to the reel, once you unwind all the string off of the reel, you just make a slip knot in the end of the wire, put it over the reel, pull it tight, make sure it doesn't move anywhere, and you're good. Nothing fancy there. I'm going to pull out just a little bit of wire here, and then we'll tighten these screws down and make sure the crank is engaged and will work properly before we go further. Okay, now does it work? Yeah, see it pull the wire in. To pull the wire out, just pull it out like so. No big deal. Take it, wind it in. Hook the pliers. Doesn't that always work like that? Something gets hooked on something. But what we have here is 41 feet. Actually, a little bit more than 41 feet. Always cut an inch or two too long on purpose, but that way we can tune it. Well, you say it's not connected to the balun. Well, that's the interesting part that we're going to get to here, and that's the reason. Could you attach this to this? Probably. Would you want to? You might. I don't know. You could, when you had this apart, you could put some. Well, here you go. You'd have to drill some extra holes and such, because you got to allow for these screws here. I was going to say you could screw the back of this onto here, but you'd have to have access to these screws to put it all back together, which could make it more difficult. I chose to keep it into two different pieces intentionally, because, you know, I may want to do something to this. I may want to use this for something else, where I'm not, you know, permanently tied to this chalk line random wire antenna. I've got options. So, well, how do you attach the two? Zip ties. What I did was, here in the base, I drilled a hole. You know, I looked on the inside to see how the thing was built, but I drilled a hole all the way through. So I take my zip tie and there it is. Get a hold of it there. Now, here we go. I've got extra hole drilled here. Put the zip tie through. Well, how close do you want it? Up to you. But here we go. And now I can cut off this excess tail here. And what do we got? We've got a rewindable antenna. And we still don't have the connection, but that's what one of these is going to be for. I've got an alligator clip on these two wires. Well, how long do I need it? Well, it depends on how I want to connect it. What I'm thinking is I need to pull out all the wire to where it's at its full extension, and then trim off some of the insulation, and I can access it right through this hole here. And that keeps the break in the insulation on the inside here, yet I can access it with my alligator clip. All you got to do is reach in there, clip it like that, and you're connected. Now, one thing that we've got to be aware of, this piece of wire right here is going to be part of the antenna. So you have to be aware well, how long a wire are you going to use? I think this one here is going to be long enough. And I'll put that right there, connect it right along with the antenna lead off of the unun. Okay, so let's take the nut off and the washer. We'll put that connector right on top of the other one. Put the washer back on, tighten it down, and take it off the side there just a little bit. Get my wrenches, pliers. How do you like these little pliers? These are vice grip. They're old. I think these were my dad's. I don't know where I got them, but they're small. I guess they're, I don't know, what are they, 4 inches, 5 inches? What are they? They're almost 6 inches. I don't know if they qualify for 5 or 6 inches. But I'll hold this nut on this side. All right. And then tighten this nut here. All right. So now we've got our coax connector here. This can be our ground or counterpoise if we choose to use one. And this is our antenna connector up here. And it will connect here. I'll go ahead and pull this out now. So go ahead and unwind all the wire. It's just a little over 41 feet. And again, you do that, you always go a little bit longer than what you need. That way, if you need to trim some, no big deal. If you need to add some, you shouldn't have to add any if you go long to begin with, okay? But just pulling it out, okay, that's maxed out. So we can use something to hook the wire and pull it up a little bit. You can grab it with some needle nose, whatever. And then as close as you can here to the part that's connected to the spool, in my opinion, is where you want to trim the insulation off. So let's see if we can trim some of that insulation off without cutting the wire. And there's probably a better way to do this. All right, there's some wire showing there. I didn't take a lot. Get in between the insulation and the wire. And there. And I think what I want to do is put a drop of solder on that. My thought is, I'm hoping there'll be less chance of cutting those individual strands of wire over time. You know, it's not going to do it right off, but, you know, clipping and unclipping, clipping and unclipping, it might wear through one or more of those wires. I'm going to put a little drop of solder on there. I think it'll help. May be wrong. Leave me a comment. Tell me what I'm doing wrong. I generally don't have to ask for those type of comments. I get a lot of those. Okay. I think that'll make it stronger. And As you can see here, now, hopefully you can see that right there? Should be able to clip right onto that. And it may need a little more insulation off of it. So let's pull that back up through. All right. Make it just a little bit longer, and hopefully I'm not making a mistake by doing that. There it is. Get that off. I'm trying to be careful, so it's taking me longer. I'm not real good at fine detailed work. There it is. All right, so I'm going to touch that again with the soldering iron. Put just a little dab of solder on there. Get it heat up, get it flowing. Very good. Now I think I'm happy with that. Oh, I got a blob of solder hanging off. Didn't see that. Get that little blob off of there. There. Now that'll work. Get some of these tools off of here. All right, so what have we got? We can get to it through the door with our alligator clip. So just clip it on, just like that. So we've got, what is that, 5 or 6 inches? Let's go here. That's from 14 to 21, so that's 7 inches. 7 inches there. So we'll need a little less than 41 feet of wire. And I did a rough measurement earlier. We'll take it out and set it up and measure it and make sure how long it is. We'll hook up SWR meter, the NanoVNA, and the tuner. Remember, since this is a random wire antenna, it's not supposed to be resonant on any frequency that we're going to be using, or even a harmonic of a frequency we're going to be using. That's why it's 41 feet. People that are smarter than me figured that is not a harmonic or a primary frequency that we're going to be using. So 41 feet is what we're going to be shooting for total, and this is 7 inches. So we'll get outside, we'll get this strung out, get the tape measure, and I'll measure it and see how long it is total. Stay with me. Let's go outside and get this thing set up. Okay, we've got our 9-to-1 unun and our chalk line random wire antenna. I've got a tape measure strung out here between this post and another post down there. 41 feet to this point right here, 41 feet. So I'm going to go attach this to the other end and then bring it back and see how long this is and how much we'll need to trim. I just hook it over the top of that post there and reel it out. Then I'll pull it to the same tightness as the tape measure is. Yeah, we're quite long here. We've got way too much, but did that intentionally. So I need to cut off, get the same sag in it here. There's 41 feet right there. So how much do we need to cut off? Get this right on 38 feet. I need to cut off 2.5 feet. Actually, once you include this as part of the antenna, I need to cut off 3 feet. Okay, I went and got the wire. Well, at the end, I've got that little loop in it where I had it hooked. So I need to cut off right at 3 feet. I'm going to cut it a little less than that. So put it on 38. There's 40, so that's 2 feet. I'm going to do it to 2.5 feet initially. If we need to cut more, we can cut more. So cut off 2.5 feet. I'm going to put another little loop in it because that's handy for hanging it in a tree. I've got some zip ties. Going to put on there. And pull it tight. And that's tight. So we'll cut off that excess. So now we'll have 41 feet and a few inches. And that should be very tunable because I think between 41 and 42 feet, possibly even a little more, is not going to be resonant with any of the frequencies that we're going to be operating on. So now I'm going to get our string and weight and put it up in this tree limb like I have in the past, which is a little over 20 feet up. And then we'll terminate it here. And I've got to go make my 16.5 foot coax. Haven't done that yet, so need to run do that. Just be a second for you, be a few minutes for me, so be right back. Okay, we have our 9-to-1 unun here, and it's connected to the chalk line random wire antenna with 41 feet of wire, including this bit here. We might have a few inches over 41 feet. And the wire goes up into the tree there. So we've got the end of the wire 22 feet or thereabouts off the ground. Now back down here, we've got the coax connected here. You see how I'm using the hook there over the post to hold it. That's a strain relief. And there's just a little weight on this coax here, not much, and because it's going back to my common mode choke. But this coax is going to be the counterpoise. It's 16.5 feet long. So from here back to the pole there, 16.5 feet. And then here is I have one of our common mode chokes. So that doesn't let the RF come down the shield any further. The RF stops here. And you can see the common mode choke there. This is one that we built in a previous video, and I'll leave a link to that so you can see that. And then I've got 50 foot of coax that is running around on the ground, going back over here to the beast. So we're going to set up, do some testing, and see how this antenna responds. So stick with us. Okay, we've got the antenna set up with the 9-to-1 unun. common mode choke. And we're going to connect the NanoVNA to see if it's resonant, and if so, where. So let's look and see where it is. Okay, we've got a few dips on the screen here, but is it at any of the frequencies we're going to be working? I don't think so. This one right up here is at 24,635. 24,635 is just below the 12 meter band, so not a problem there. We can work 12 meters and it won't be resonant. So let's see where this one here is. Move the marker there. That marker's at 17,167, down below the 17 meter band. So it's not a problem there. Let's see where this other dip is. That marker's at 8.757, so that's outside the bands too. So the antenna is not resonant on any of the bands we're going to be tuning. So that's the way it's supposed to be. We're supposed to bring it in to tune with our tuner for the radio. So now let's get connected up to the radio and tuner and see if we can tune it in. What I've done is I've connected the tuner in between the antenna and the NanoVNA, so we can see what introducing the tuner does to the resonant frequencies. You see we've got multiple dips across the bands now, but they're not where we need them to be. And I did a little bit of experimenting so I wouldn't waste a lot of your time to see what it would take to get it. So we'll start out in the 80 meter band, okay? Right now I've got the tuner, the transmitter matching is on 0, the inductor is on A, and the antenna matching is on 0. Because what I'm going to do, see right now, I've got the marker right now at 3.827, okay? 3.827, which would be in the 80 meter band. But it's not near any of these dips. So I'm going to leave the transmitter matching and the antenna matching knobs alone, and I'm going to change the inductor, and you can see they all moved. Change it again. It takes it a minute to do the scan, but I found that down here on inductor selector F is getting close, so I'm going to change to where I'm just seeing the 80 meter band plus a little bit. I'm from 3.5 to 4 megahertz, okay? And you see where the dip is. And what I'm going to do is I'm going to turn the transmitter matching first and watch what happens. And turn it slowly. See how the dip is getting lower, and it's going up a little bit in frequency. But right there, you know, it's 1-to-1 SWR, but it's not at the frequency that we want. What is that frequency there? That's 3.6. Okay, so let's tune the antenna matching a little bit, and you see how the resonant frequency is getting higher. Let's see where it's at now. And it's right around 3.7, getting closer to what we want. Okay, so I'm going to turn it a little more. Let's go ahead and put the marker where we want it to be. So I'm going to say right around 3.8, because again I work sideband. Okay, there's 3.8 right there. So that's on the low side of sideband for the general class. And let's see if we can get that a little closer. It's real touchy, doesn't take much adjustment. But look at that right there. 1.08 SWR, 1.08. I would say it's pretty good. And I might be able to tune the transmitter matching a little bit and get that dive a little deeper. Look at that. Now I can go back to the antenna matching and move that. Oh, it is sensitive. But you know, anything close to that is going to be great SWR. So it's not a problem. It is tuned in on 80 meters like a champ. So let's record that. I'm at number 1 for transmitter matching. I'm on the F inductor, and I'm on about 1.75 on the antenna matching. Okay, and this is on the MFJ Deluxe VersaTuner 2. So I'm going to record those, and then I'm going to do the same thing for 40 meters and we're going to go through all the bands here and make sure that this thing tunes up like it should. This is really interesting, playing with this, and it does take a few minutes to work it out initially, but as you can see here, I have tuned it. We're at 7.235 megahertz, and we've got the dip there. I'm going to change to the 40 meter band, or tighter around it, and look at what we've got here. Extremely low SWR across the band, and there's 7.23. I'll get on that. That's frequency close to where I like to tune all the time. All right, there's 7.23. Look at the SWR. We're at 1.069. And the setting that I'm using on the MFJ Deluxe VersaTuner 2, about a 1 on the transmitter matching. I'm using inductor I, and antenna matching is on about a 2. So again, this random wire antenna that's not resonant on any of these frequencies is tuning in extremely well. So we've got a tune for 40 meters. I'm going to write that down, and then I'll go on up to 20 meters. We're scanning 1 to 30 again, and I've found what it likes for 20 meters. It's going up here to 14, bottom out there. That's 14,267 on this scale, and we've got a extremely low dip there. So let's go to the 20 meter scale, or it's actually a little wider than 20 meters. But look at the curve there, how flat it is across the entire band. That's at 14,242. Let's look at 14,230 or 225, somewhere in that neighborhood. There's 14,230, which we're still, I mean, 1.07 SWR, and we're on transmitter matching 0, inductor A, antenna matching 0. So 0A, 0 on the tuner, which what I'm trying to do is I'm trying to use the lowest numbers, because that's where you got the most, where the capacitors are at full mesh, is at 0. And I'm seeing what I can do by just changing the inductor, and it just worked out that inductor A is what this thing liked. So at 20 meters. So again, very good tune. High mesh on the capacitor, so you get the less loss, you know. And it makes sense now that changing the inductor, you know, an inductor, what does that do to an antenna? It makes it longer, and an inductor makes it longer, and we're changing taps on the inductor. So by leaving the knobs at 0 and then getting it close just by selecting the inductor, brings the antenna into tune for the band we want to use. So I'm going to continue with that, and again, leaving the tunable capacitors at as close to full mesh as possible, and then changing the inductor to get it the most efficient tuning that you can get. You know, there's always some loss in a tuner. It's unavoidable. There's always going to be loss in a tuner. But the more the tunable capacitors are meshed, the less loss you have. So let's go on up to the 17 meter band and see what we can do there. Okay, we got it tuned in on the 17 meter band now at 18110. This one's a little different. Got a good SWR tuned in, not a problem with that. But it's probably not going to be as efficient because my transmitter matching is set on a 5. My inductor is on J, and my antenna matching is on a 5. So it's going to tune, it's going to work, but it's probably not going to be as efficient. And but no problem tuning it in. I played around with the inductors quite a lot trying to find one that would work. Let's go ahead and go to the 17 meter band. Okay, here it is on the 17 meter band, and we're tuned to 18110, and you can see it's pretty much flat all the way across, starting out at 1.027 SWR, and I don't think it's going above 1.5 SWR. Get it across there and see. It's at 1.142 SWR. So again, very good. Antenna's tuning up very good. Not a problem whatsoever tuning it in. So we'll record this and then we'll go on up to 15. Okay, here we are at 15 meters. We're tuned to 21.227.5 at the moment and got a good reading here. Let's go to the 15 meter band and see what it looks like. Down here at let's go to 21.275. There's 21.275. We're at 1.136 SWR. Let's see if we can tweak that a little bit. Okay, we're tuning 1.128, 1.130 SWR in the 15 meter band. So very good. It's on transmitter matching about 4.5 on inductor A, and antenna matching 0. So that's where we've got the lowest SWR. Very good tune for that band. Okay, we've got the antenna tuned in on the 12 meter band now, and it's tuned in very well at 1.2 SWR. You can see right down here the frequency is at 24.925, and the tuner is on 0, J, 1.5. So the transmitter matching is on 0, the inductor is on inductor J, and the antenna matching is on 1.5. And that's a very good SWR, very good dip there. So we'll go ahead, and I don't have the 12 meter band in the individual bands, but I do have 10 meters. So we'll go ahead and tune for 10 meters and see what we can get there. Okay, we've got it tuned in on 10 meters now at 28.332 on this scale. 1.4 SWR, which not bad. Not as good as the others, but not bad. Got it on 5.5 on the transmitter matching, inductor L, and 0 on the antenna matching. You know, these numbers and letters I'm giving you would only apply to the MFJ Deluxe VersaTuner 2, but it's as much for my documentation as anything, and just to give you some idea of where it's tuning. you got an automatic tuner or any other tuner, you'll have to go through this on your own. But once you do it once, as long as you set the antenna up the same way each time, that's going to get you in the ballpark. It's going to get you very close, and you can fine tune it after you select your band with your radio. But since my radio doesn't have a tuner in it, I thought this would be interesting where you can see the graphic representation. Let's go to the 10-meter band and see where that dip is, and you see it's way over here. And this is from 28.3 to 29.7. And see if we can tweak it just a little bit and see if we can improve it any. That raises the SWR a little bit. I think we're pretty much tweaked out about there. But you see the dip as you go up higher. And you can move this if you want to work a different part of the band, but you just got a sharper dip here. As you can see here, I'm going to change where the resonant frequency is. Okay, you see how the resonant frequency is moving up the band by me changing the antenna matching. So if I wanted to get it in the middle of the band, you know, here on this end of the scale, we've got 2.6 SWR, and it goes over 3 over here. That's just by changing, you know, the tuner. So you can tune it to whatever part of the band you want to use. But anyway, that gives you some idea that this random wire antenna that's not resonant on any of the frequencies that we're going to be using can be easily tuned in to whatever frequency you want to use. I hope you've enjoyed this video as much as I did making it for you. Learned quite a lot. Enjoyed building this 9-to-1 unun, using it with the chalk line antenna that we built. Give me a thumbs up, like, comment, subscribe. If you're able, throw a little support my way so I can keep making more of these videos. This is Jerry, Kilo Mike 4, Zulu Kilo Bravo. Have a blessed day.